I'm John Valvano. This is my EE319K class. We're about ready to come up on a fun and exciting and dangerous and nerve-wracking and exam next week where the students are asked to, we're giving them a problem, we give them a few minutes, and at the outcome of that exam is they can program some simple questions and some hard questions. Well, there is class, so I would like to entertain questions before we begin. Yeah.
In general, how big should I make numbers? Should I make them 32 bits or?
Oh, an interesting strategy. So the question is, what's your strategy for making numbers? Okay. In general, I would say on the ARM architecture, it's either unsigned, in which case you make it 32-bit unsigned, or it's signed, you make it 32-bit signed while you're manipulating the numbers. That way you have the minimum amount of overflow possibilities. And then at the end of the calculation, you demode it back to whatever type it's in. So when you're making local variables and you're manipulating an 8-bit signed number, make it a 32-bit signed number. If it's a 16-bit unsigned number, make it temporarily make it a 32-bit, and then at the end you can demote it back. That's the general answer to your question. The specific answer to your question has to do with passing all the test cases. Right? So it's got to compile, and it's got to run, and you get 55 minutes or whatever we give you to get this done. Did I answer your question? Yeah. So now, outside of the ARM, you may need 64 bits or 128 bits, right, to get the right answer. But I do believe in this particular next week, it probably is not going to matter. But I still would say the best way is to bump all your internal variables up to 32 bits and just make it signed or unsigned as needed. That's probably the best answer in all cases, including the exam. That's a good question. Any other questions? This is you're going to get something like this, and as you download it and try examples, you'll see that the syntax of this is typical. What you'll see down here is the amount of time that you have to do it will depend on the complexity of the problem. And that semester, when do we do it? We do it in class. Like if I were to do it in class, they would have only had 45 minutes because 40 minutes or 35 minutes because it takes a certain amount of time to wind up and wind down. We have not negotiated this number yet for you particularly, but we will begin at 7. And we'll clearly be done at 8:30. Okay, so it won't be longer than that. The other thing you can tell from this is this score is TA writes this in here and signs it. This piece of paper is given back to us. It is closed book, although you have your laptop open. But according to the official rules, you are not allowed to access anything other than Kyle and the Kyle help. The Kyle help used to be a bigger deal when you were programming in assembly language because the entire assembler syntax and all that crap is actually in the help system if you knew where to find it. But once we're doing it in C, I don't believe there's anything in the help that you should be looking up. So if you'd like to have a calculator open, that's not cheating. You can have a calculator open. So while you're doing it, you have just the microvision and the calculator. And obviously, you're on the internet, so aiming and Skyping with other people is inappropriate. Obviously, anything. So basically, the TAs walk around the room and watch your screens. Okay, that's really what we do. I don't know if everybody will do it, but there is a process that we get you, which gets you launched, and there will be a website that you will go to. There will be a username and a password, that's shared for all 400 of you, and at that point you'll get a zip file, and that zip file then will be downloaded somewhere. Now what we encourage people to do is put it on the desktop, because at the end you got to upload the answer to Canvas, and people go, I've been working for 40 minutes, I don't know where it is, okay? Because the project will actually compile anywhere on your computer. I would encourage you, this is the other thing that people spend a long time doing. That's the answer. I don't want to do that one. That's the answer. I want to go to my desktop. Go to my desktop. Go to my desktop. There's the answer. There's the internet. We don't want the internet. Okay, here's my... Okay. I don't know if your projects look like this, but this is what it looks like on my computer. And so when it's time to upload, the answers are to upload the exam2.c file right here. And if you don't have Windows show you the extension, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 exam2 files on your computer. And if you just guess, you have only a 10% chance of uploading an actual C file. So I'd encourage you to activate your Windows operating system so it shows you the extensions. You with me with that? This happens all the time. Somebody uploads the D file, and that's like totally useless for grading. Okay? All right. So... Now, all of the 7 or so example files that are up there all sort of work in the same sort of way. You write code, you get a grade. Sometimes this sheet is useful information in it, like some pictures. But in this particular case, there's nothing really in here that's this particular one. There's really not much there. So I'm going to go over to the application. So I've opened it up. The first thing that you shall do is to build it and program it. I mean, it's going to be simulated, so it should all be set up for you. And you should find a UART1 window. And people go, I don't know where my UART1. I've lost my UART window. So you go over to View. You go down to Serial. And there it is. If you wanted to activate if for some reason it was gone, you don't know where it is, you can activate it up like that. Since it's been compiled and we will run it, you'll see that we got no score. Okay? But this window here did show you what the correct answer was. Okay? Now, it doesn't tell you what you did wrong, but it... okay. All right, so now we're going to... Questions about starting? This lets me know that you've downloaded it and you're not trying to execute out of the zip file. People try that. It doesn't work. You got to have write access to the folder. Some of your operating systems don't let you write anywhere. So you have to put this project somewhere where the compiler can write into. All right. Exam 2. Questions? All right, so now I'm just going to go through the strategy of doing the exam, and it's probably a good idea to start at the top and get some points. So I'm going to start at the top. I can see that I'm going to, we're interested in pointers. We talked about this last time. There's 2 ways for you to get the first character. Right? So if I have a character and I have a letter, if I want to get the first character, there are 2 ways that I could get it. What are those 2 ways? In general? Indexed and pointer. Okay? Oops. Two ways. Which way do you like better? I don't care. Okay. I have violated my rule, by the way. You said what size should it be? Okay. If it's character, leave it a character, because I'm not actually going to add and subtract it. So in this particular case, I have a letter that I'm going to just read. All right, again, a strategy is to create a local variable of the same type as the return. Okay. This is going to have a return type of UN, so I'll create an answer. I do see that it's possible that it's going to be a null string, and so I will, we've done size a few times before. I will populate this with an initial guess, and then now I'm going to do a what type of loop is this going to be? A while loop, because it may have none. So I'll do a while. And those were just fun things. I don't actually need them. So I'll take them out. All right. Any questions on this? This is going to run. It's probably not a horrible idea to put a breakpoint here. So I'm going to build it. I'm going to run it. I'm going to run. Now, often, in most cases, you're not going to see a main program. This one we built incorrectly somehow, and it shows you the main. I promise you, when you go it, you won't see main. We'll hide it from you entirely. But it is interesting for you to see. Now, in this particular case, what am I expecting string to be? Right? I'm expecting it to be, right? And so one of the things you can do in the debugger that you couldn't do in assembly language is look at the local variables. In particular here, it will show me the parameter right there. You see it? Right there, and there's what it got. So the answer is going to be 4, right? The answer is going to be 4, and then I'm going to single step over it. All right, increment answer. You see answers there. You see it right there, and then single step over again. Oops, crash. Oh yeah. Oh good. No, good. There is a bug. Nice, nice, nice. Let me just show you what would have happened. Let me just show you what would have happened if I just pushed the go button. Ah, sweet. I didn't mean to make a mistake, but if I were to have pushed the go button, that's what I get. And people raise their hand and they go, "Hey, Johnny, your grader's broken." I get that. We get that a lot. Smart people out there already see all my bug. I didn't do it on purpose, but I do make mistakes. No matter, it doesn't matter how simple a program is, I could make a mistake, right? But you see, you can sort of visualize. Let me put the breakpoint back, right? Let me put the breakpoint back and reset, run over here. Yes, run. Yeah, run. Front row guys can see what's happening. Tell the back row guys what did they see. The answer keeps going. You know, if I were to hit the run button, and now the answer, you know, could the answer be this? Probably not. Okay. So I have I have a bad program. Okay. What's my bug? I didn't increment the pointer. Okay, so I should have incremented the pointer. String looks like an array, but it's also a pointer. And now it's, I'll leave the breakpoint here this time. Build. Don't forget to build before you program it again. Sweet. Oh, nice. Stop. Undefined line number. Oh, this is an interesting bug. Not a bug. It's a situation. You see this situation right here? You see that? That's the difficulty of setting breakpoints in the editor. You can only set breakpoints where it executes. So restart. Right there. My answer is 11. That can't be right. Did I make another mistake? Okay, let's restart. Four. There we go. That's the other way to see a local variable. You see, I just hovered over it. The answer is 4. Yeah, there we go. 4. And then this. Let me remove the breakpoint. Go back to the UART, and you'll see I would have gotten 25 points. There we are. So you should be able to get to 50 pretty quickly in these exams. That's the other strategy that we have is scores less than 50 usually are a poor sign for something. And okay, so let's do another question. Average. This one's fairly simple. You saw that there were 2 ways for us to have variable length arrays. The first is to have a sentinel at the end, like the string, and the second is to encode the size in some other place. In this case, it's fairly simple, and that is, okay, so I'm going to calculate the average, so I'm going to need a sum, and this is where it gets to the question of the type. I'm going to create a variable called sum. Okay, and in C you can save yourself some space by initializing that variable. You see that I've collected a signed 32-bit number into which, now if you look at this and you look at these numbers here, this is where you would see that if this were an 8-bit variable, it would still work because the sum never went over to 128. Okay, because we tried not to make it, but a more powerful thing. All right, so this is I'm going to need an index. I'll do this one with indexed for I equals 0, I less than size. You notice the compiler lets me see my errors as I go along. I plus plus. Sum equals sum plus pt bracket I. Okay. Return sum divided by size. Okay. This time I purposely put in a bug. Or not. I don't know what's going to happen here. Does somebody see my bug? What's my bug? What? Oh, yeah. I didn't cast it back. I don't care. If it compiles, we don't have to cast it. Oh, I did get a warning. Okay, that's my unreachable stuff. I got to divide by 0. Okay. Now, I don't know what happens in this compiler if you divide by 0. I remember I'm an old guy, remember, at 62 years old. And one of the first computers that came out was the IBM PC in the original 8088. And you were running DOS at the time and Windows 3.1 and all those fun things. And if you divided by 0 on that, you got a blue screen. It was awesome. It was unimplemented hardware fault on that processor, divide by 0 fault. I don't know what happens in this processor when you divide 0 by 0, right? I don't know what happens. We're going to find out because I didn't test this bug. but again, it makes sense for me to put a breakpoint and watch it. Okay, so I'm trying to model good behavior here. Don't just hit the go button. We're going to put a breakpoint somewhere. Now, at this point, we know what size should be, right? Size should have been a 5. That's the first one. Okay. Pointer should have been, oh boy, now what do I do? How do I observe the array? You see that? Okay. If you can remember 8BC, you could come over to the memory window and type in 8BC. And there's my array. There, the 1, the 4, the 3, the 3, the 4. Okay, there's my array. What we like to do to make your life miserable, okay, is right after the array, we're going to put a bunch of crap in there. This is a bad exam. I should have put a bunch of crap in there. That meant if you try to access it, you're going to get the wrong answer. But this one I didn't. I can see that. So I'm going to step over. I can see some. Over here should grow. I should grow. I should be able to see. All right, so I'm calculating size. Now the disadvantage of this code is I can't see what it returns unless I'm looking at unless you're smart enough to look at the register or up here, right? You can see if I single assembly line structure, what's this, by the way? What's that? That's the divide, okay? So I can see that it's going to take R4, which is a 15, and divide it by R2, which is a 5, and it should return, if I single assembly language step this, that's the other thing that I often like to do is understand the code, and now I can look in our register R0 and see my answer. This is the demotion, by the way. But in this case, it's not going to be a matter. So then it returns. So I'm empowered, and so I'm just going to hit the go button. Oh, so go to the next one. Yeah, it's another breakpoint. Go. Correct. Okay. So let's see. Did I get it right? Test of grade. All right, I got a bug somewhere. Look at all the bugs. I got some bugs. Okay, the correct answer is -1, and I gave a 104. Yeah, I don't know what happened there. All right. So what I want to do is I want to be able to run the case that I got wrong, right? I still don't know what's wrong, so I'm going to run the case that
Your sign is unsigned and everything else is stopped.
Yeah, I understand what the bug is. Yeah, I'm just trying to pretend I don't know. Yeah. So you want to fix it, right? So what I'm going to do is create a signed size. Is that what you want me? How you want me to fix it? Yeah. In fact, I got a bug, and so why don't I even make something which is of the type of my answer. Right, so that I can see what it's doing. Right, so I'll put the breakpoint here instead of there. All right, you see how even I made the code worse, if you'd like. Do you see how I made the code worse? How did I make this code worse? It's more verbose. Right? I created variables when I didn't need them. But why? Why did I create all these extra variables? I could be easier to debug because I didn't get the right answer. And so now what I want to do is to be able to see. Now I can do that either by watching the C code, the assembly code. Okay, so the first one worked. Remember, the second one is the one that didn't work. So again, this was 15 divided by 5. And I step over, and it created an answer of 3. That one's run. That one ran. The second one was a size of 10 things and an array. Okay, there they are. There's my 10 things down there. I could go over here and I see that's at 8E8. Okay. And you can see I've got a bunch of negative numbers in there, which is now the question is my sum correct? So if you were to do your math here, that should have given me a minus 10. Sum should be a minus 10. You see that? Minus 3, minus 10, plus 1 and 2 should have given me a 13. Then I go down and look at my sum and I go, oh, what's that? I go, help. Okay. Is that a minus 10? Somebody say yes, that is minus 10 in hexadecimal. Okay? It is. Now, if you don't like that and you go, well, how about this? How about if I change the type here? Right? So change the type into decimal and I can see it actually is minus 10. And then I will step over, okay? And I will step over right there and I see my answer is now minus 1. So I fixed that one mistake. You see what I did? Run again. This is another example. We see that pointer here is 914. I go back over here and I can type in 914. There's my array. Okay, so I'm going to get rid of the breakpoint and run some more. So what the mistake I made was mixing and matching the types. I had unsigned and signed numbers, and when I do a divide by a signed number divided by unsigned number, it doesn't know what the result should be. Okay, so when it's okay to divide a 32-bit number by an 8-bit number, but you got to make sure they're both signed or both unsigned when you divide. What's the other instruction that it matters? Divide. Which opcodes are different for signed and unsigned? The branches. The branches. So a greater than or less than is going to matter. You can't take an unsigned number and compare it to a signed number with a greater than sign or a less than sign. What else? Add, subtract, and multiply don't matter. But there's one more that does. Right shift. Okay? Right shift, it matters whether it's signed or unsigned. All right. All right, so I got rid of the breakpoint and go back to my UART, and we'll see how many scores I get here. All right, I'm up to 50. All right, there we go. Let's keep going. All right. All right, so now this is an example where it's sort of building on each other. And so what I'm going to do another average, but I'm going to skip some grades. So this is like in Canvas where you go to the end and it looks like you got an A. That's because we just haven't entered in your grades yet, right? It looks like your average is really high, but you haven't even done the next lab yet, so we've not added it in. And then eventually you get that final exam grade and you go, oh, my average isn't quite so high as I thought it was. All right. So again, if you go back up here, you see that the data is signed, right? The data is signed, and so I'm going to need a signed. Now this is probably an example where I do want to use a sum which is bigger than 8 bits. I want to use a sum which is bigger than 8 bits. because these numbers will, this sum will indeed get larger. Okay. I'm going to need an index, so I'll just use any old index. Now in this particular case, how big are these arrays? How big is these arrays? Always 8. But I'm going to skip some data as we go along. So I'm going to have to know how many pieces I have. So I will create another variable called count and initialize it to 0. That'll tell me how many. You notice that 0 divided by 0 got me the right answer, by the way. Did you notice that? 0 divided by 0 turned out to be 0. Just lucky for me, because that's also going to play the case here for this last one. It's not going to find any. For I equals 0, I less than 8, I plus plus. Right? And so what I want to do is access that structure, right? So one of the cool things that the assembler, the editor does is look at it's saying help, don't mess up. You see what it's doing for me? It's telling me the two things I could potentially type next, right? And anything other than those two, it's not going to work. And there are two ways to access the structure, right? The dot format and the pointer format. I passed you the structure itself, and so we're going to use the. All right. Now, what do I have now? I have what is it that I have in my sites on line 91? What is that? No, it's not the first element. Data is a what? Is an array. A single one-dimensional array of 8 things. And so in C, when I give you the name of an array, what do you have? You have a pointer to the beginning of that array. And if you have an array to a pointer, what are the two things you can do to get the data out of that pointer? You can index it or dereference it with a star. In this particular case, I'm going to, oops, not there. Put that there. I'm going to index it. Okay? Now what do I have? What do I have now sitting in my sites? I have an element. I have an 8-bit signed number, okay, that I can store into a 32-bit signed number. Okay, you see that? Now it's a bad idea because I didn't handle the case. I didn't handle the case where there's some unused numbers. So in this particular case, the only one I'm going to get right is Wusik, because Wusik's the only one with full grades and lots of extra credit, right? So what did I do in the last case to make it easier to debug? I made extra variables. Okay, so I'm going to do the same thing here. Now, I don't know if you... Okay, I don't make two things of the same type, same name. That may work. It's probably... let's just call it X. Okay. All right. Now I'm going to actually did this for a purpose, and that is how do I skip a 128? Right? I just go if x is not equal to minus 128. Then yeah. Okay. Okay. See what I'm going to do. confused? All right. So, what do I expect count to be? Right? Yeah, fine. Let's make another one. Answer. What do I expect count to be first time through? This is what you do when you debug. It's got a fancy name called desk checking. And that is, I'm here at my desk, I'm checking it. First time through, see how I made the numbers so easy for you you don't need a calculator for this? What do you expect what do you expect count to be first time through? 4. What do you expect sum to be? 400. And what do you expect average to be? 100. That's what you expect. So what we're going to do, and this time I'm not going to let it trick me. I'm going to build it. I'm going to debug it, and then I'm going to put the breakpoint in so that I hit a spot, right? And then I'm going to put a breakpoint right here, right? Because you can only put a breakpoint where there's a gray. And then I'm going to run, and I'm going to look at count, right? Again, I can hover over it, or I can go over here and look at it over there. And I go, oh, John, nobody likes it. Stupid hexadecimal. Get rid of the hexadecimal. There we go. 400 for the last answer. And the answer is 0. That's because it hasn't executed yet. So I step over, and my answer is now 100. Again, I'm at least empowered to hit the go button. And I don't know if I missed any. Oh, I missed one. Oh, no. Go, hey, John, I thought 0 divided by 0 is 0. Well, it is, but if you read the directions, it says, if you read the directions, it said, right up here, return minus 128 if there are no grades in the list. So that's the one I got wrong. So yeah, hey, next time read the directions. If count equals 0, return. Come on. Now this may not be a better answer. Answer equals minus 128. This was came up in the discussion. This came up in the discussion last time about whether there should be multiple return points out of your function. What I am encouraging you to do at this point is to develop a strategy which is fastest for you. If you're inclined to be able to solve the problem in a better way, go for it. But this way here, I have one return statement for the entire thing, so I can actually look. I can actually put a breakpoint right here. I expect it to happen, right? I expect it to happen once, right? I do. And so I will put a breakpoint right there, and I will run it and see that I get exactly one breakpoint right there on the case where the answer. And you go, hey, John, why is the output delayed, right? Because I'm in the 5th run. But it hasn't outputted the 4th yet. And that's just a physical thing. We'll learn that in Lab 9. There's a 16-character buffer between the software and the hardware, and this implements all 16 characters. And so you're behind 16 characters at any given time in that display. All right. Run. All right. All right. 75. I'm now one more. Stop. Debug. Okay. Where are we? An exam. Okay, take away that one. All right. So now this is an array of structs, and so now I got to be careful and look at what this is. What's given to me is an array of structs. So if I were to look at R0 at the beginning of this function, what would I have? What is in R0? A pointer, right? What's in R0 is a pointer to an array of structs. Okay? So this is a pointer to these arrays. So what I want to do is sort of try something. Okay? So for instance, if I want a number, I could do these are just like the other ones. These are going to be int 32s. Okay, I'm going to promote it up to a signed number, and let's make an x. And let me just try. Can I get the 100? Right? Can I read? What's the syntax for getting what I want? Right? So I want to get the 100. This one right here. Right? And so what I'm going to do is I'm going to access the first element. Okay? And I'm going to go dot data bracket 0. Okay? That is going to give me the 100. Okay, so let's get Ben's 110. Let's try a harder one. Let's get Ben's 110. 0, 1, 2, 3. Well, we'll single step it and just do another one. I'm going to single step across here and see what happens. What is 0, 1, 2, 3, 4? All right. Okay, I'm going to test my knowledge of being able to access the data. Right? Before I just jump in and start raw coding, do I understand what was given to me? Okay? So I'm expecting, right, this one to be 100. I'm expecting, and to make a life easy for me, let's just call it XYZ. That's the way that way the debugger is. See, I'm learning, right? I'm expecting this one to be what? That's minus 128. That's this one up here. And I'm expecting this one to be 110. Right? Again, right? Put a breakpoint here. Build. Now, warning. Okay, compiler. I set the variable to never use. It's a little bossy, isn't it?
Yeah.
It's a little bossy. It may totally throw it out. It might have. So, boy, I don't know what to do. Let's just see what happens. No, it didn't throw it out. It actually did it, I think. Yeah, it did it. Yeah, so it wasn't horrible. Right there. So x, again, it's x was 100, y was minus 128, but z was wrong because it obviously hadn't executed that line yet. So now z is 22. Right. So you see how I have I've used the debugger to help me understand I used the debugger to help me understand the all right, so okay, so now I'm looking for a maximum. So my strategy for finding a maximum is to set myself up with a maximum, which I'm going to initialize to a very big small number, right? And if you look at this, you can see as long as I choose a minimum, right? What's the smallest average I can get? And that's 0. And so if I just set this to be -1, I will find the maximum. So you're going to initially set the maximum to the smallest it can possibly be. And then I'm going to have to do my average. So I'm going to need the same thing I had before, or you go, hey, can I use the other function? Can I use this function? I certainly can. All I have to do is get a doodah. So I'm going to actually use the function. So somewhere in here, I'm going to need an index. I don't need this anymore. And you see what I do with code that I don't need anymore. I can comment it out because I may change my mind and want to put it back in there. How many students do I have in this class? Right? If you go back up here, there's only one test case, and there are exactly 10 students for I equals 0, I less than 10, I plus plus. And so I'm going to find the grade for student I by calling this other function. Okay. Again, I don't like to use variables and function names the same, so I'm going to change that variable name here in a minute, even though it's lowercase. So I'm going to go something shorter. Score. Okay, so what's the type of this function? It has to be a student, and so now I'm going to very carefully find something that is of that type. And so that may be enough. I could put a breakpoint there and see if that works. We only got time. So let's go. If this student here is higher than the max, then I will set max equal to score. All right. Let's put the breakpoint here because I do think that's a good idea. Build, debug. So sometimes it's a good strategy to reuse your functions. Okay, so what am I expecting score to be?
9.
No, right here, score. Right? Score is the score of Johnny, which is going to be 100. I'm expecting it to return me 100. Okay? That's what I'm expecting. Right? There it is, 100. Okay. Now, did I read the directions? Find the student with the highest average. Ah, crap. That's the highest average. Okay, find the student. Ah, crap. So I didn't remember. Well, obviously I misread the question. So let me take off the breakpoint and show you that I got the wrong answer. So the correct answer was a 9, and I returned 101. You can see how I misread the question. All right, so I'm going to have to remember the student number. Yep.
You didn't put the underscore T at the UN32.
Yep, thank you. That and then return answer. All right, let's try that. And go. 100. Ta-da. Made it. Did a lot of talking. But hopefully you saw some strategies in there. I do have office hours today from 2 to 4. Come by if you're having trouble. And we'll see you. I'm gonna try.